Okay, we're now going to talk about exponential growth and decay, which is, there's a very interesting and fairly simple differential equation that is very, very important and powerful. Here it is. The derivative f prime of t is k times f of t. What does this mean? It says that the rate at which the function is changing, its derivative, is directly related to the size of the function at time t. How fast it's changing depends on how big it is in the first place. For example, suppose the function is a population. F of t is p of t, the population of something at time t. The population of a country, the population of microbes on an agar dish, the number of rabbits in a forest, or something like that. What we're saying is that the population increases, the population, which would be the birth rate minus the death rate, is proportional to the size of the population. So if you have a country with a lot of people, like China or India, there will be a lot more babies each year than a country with a small population, like Sweden. And I don't care, in China you're only allowed to have one baby per family ever each, but there's still billions of people in China. That means there's a lot more babies born each year. That means that the population of China is increasing a lot faster than the population of Sweden is changing. People of Sweden, quite charming, but they just don't have enough people to have as many babies as people in China have. In K in Europe at the moment, I've heard the number is about 1/40th. So for every 40 people in Europe, there's one baby born each year, or even one baby born more than the number of people who die. So the population of Europe is changing. A country with a large population is going to have more babies than a country with a small population. As another example, suppose f of t, the function, represents the amount of money that you have in the bank. Well, you get a certain amount of interest on your money in the bank. And the interest you're getting these days is kind of pathetic. It's 1% if you're lucky. I'm getting what is it? A 20th% in my checking account and a 10th% in my savings account. It's really, really pathetic. But still, if you have a huge amount of money in the bank, you multiply that by the rate of interest, you get a pretty decent amount. If you were getting 1% interest and you had $1 billion in the bank, they're going to give you $10 million every year. If you are getting 1% interest and you have $500 in the bank, you're getting $5 each year. So you can see how the person with $1 billion in the bank, they're gaining $10 million every year. Person with $500 in the bank is gaining $5 each year. Clearly, $10 million is more than $5. So the more money you have in the bank, the more interest, and the faster the amount of money you have in the bank grows. This is one of the many, many unfair things about life. As a final example, radioactive material, things like uranium and plutonium and unstable isotopes of, let's say, carbon. Carbon-14 is considered radioactive because over time, these unstable atoms pop and break down. They break down and they spew little pieces around. Now, if you have, how do I put this? Every now and then, these things pop and break down. If you only have a few of them, you're not going to lose that much. If you have a lot of these atoms, well, you have more of them are going to pop in any given year. So the amount of plutonium that you have, the more plutonium you have, the more you lose every year. Right. Now, if you have enough radioactive material all crammed into one space, breaking down at a certain rate, then the little byproducts flinging around will cause a chain reaction. And this is how you make a nuclear bomb or a nuclear reactor. You figure out just how much you need all in one place, you smush it together or you squeeze it together or whatever, and it causes this chain reaction. So the more radioactive material you have, the faster you lose radioactive material. Now, in the last example, your constant k is a negative number because the derivative, the rate of change of how much material you have, is going down. You are losing plutonium all the time. Whereas in a population, you are gaining population all the time. In any case, all of these situations, gaining money, gaining population, losing plutonium, they're all modeled by the exact same differential equation, f prime of t equals k times f of t. So, we are going to solve this in the next video and apply it in a number of these situations.